Good morning, everyone. Can you all hear me?
Good morning, madam.
Good morning.
Yeah, you can, right? Good morning, ma'am. Good morning. I hope you got the slides and you can see this as well. Can you see the screen?
Yes, ma'am.
Okay.
Yes,
I'm sorry. So today we are going to now. Last week we talked about what is operations management and how this OM strategy is derived. So I told you that when it comes to operations management, the basic thing is if it's going to be either a manufacturing organization or a service organization, they have to either it depends on the actually the nature of the company. If it's going to be a manufacturing organization, they have to actually develop a product. If not a service organization, they have to deliver a service. So for both of them, both sort of companies, they have to first pay attention to their target market or the market requirements, and based on that, they have to develop maybe their product or service. So we are going to talk about how a product as well as a service is designed to deliver, yeah, I would say to deliver those to their target markets, right? So today basically we will be talking about that, right? So first half of this, I would say the session or the chapter, we would be focusing on designing a product, then designing a service. So when it comes to designing a product, there is a process, right? So that means you have to generate your ideas, then I will be talking about these things briefly. Then you have to conduct a feasibility study, then there's a stage called rapid prototyping, then pilot run and launching the new product. So those are the basic steps. So we'll talk about them separately. So when it comes to designing a product, of course you have to now, for any innovation, we have heard about the light bulb, we have heard about so many innovation, it might be the iPhone and all. For every or any innovation, there's a story behind, right? So when it comes to light bulb, it is a result of maybe an experiment, research and development. Again, maybe iPhone, maybe research and development, I have no idea, no proper idea, maybe research and development, or it might be competitors behavior, or it might be customers request and all, right? So likewise, for any product, we have uh, an idea generation stage. It might be, as I told you, as a result of research and development, or it might be as a result of competitors, right? Now, for example, for iPhone, nowadays Apple company, they have competitors, right? So they, if they want to remain in the market, yes, to in responding to their competitors, they are generating new products, right? So and at that sort of a situation, yes, they should pay their attention towards to their target market, whether the customers will purchase this new version of their phone or laptop or whatever the items that they are going to introduce to the market, right? On the other hand side, Samsung might also be doing the same. In competing with Apple, they might be coming up with innovations or new products, right? So that is how ideas are generated. Apart from that, sometimes from the customers' complaints or suggestions, and based on market surveys, we might be coming up with certain design. And also maybe during the manufacturing process, some new ideas might be generated, and resultantly, some new products might be developed, right? So, in addition to above mentioned things, right? Now, for example, uh, customers' ideas or suggestions may be for, I would say, in Sri Lanka for garment manufacturing companies. Actually, for example, if it's going to be Nike, they are the one who send the product design to the company to produce that for them. So it's customers' idea. So based on the customer's idea, we might be developing the product, right? So apart from those things, we can use perceptual maps, benchmarking, and reverse engineering uh, to come up with new product design ideas. So that is again, we are like trying to pay our attention to market trends or the competitors, and based on that we are going to come up with new ideas. So if we talk about the perceptual maps, right, it compares customer perceptions of a company's products with competitors products, right? So here you are given a perceptual map of breakfast cereals in terms of taste and nutrition, right? Here, taste good and bad, nutrition high and low. So when it comes to a good taste and high nutrition, no such product is in the market at the moment. So there might be an opportunity. So based on that, you can come up with a new product idea. Right, so when it comes to bad taste and high nutrition, yes, there are some products. Low nutrition and bad taste, there's one. But I don't think in the market, low nutrition and bad taste, there would be much demand for this. So this company, they can either develop their product to good taste, or they can shift here, right? And this cocoa puff, they have good taste, but the nutrition value is low, right? So this is the perceptual map. Now we'll see what they can do, right? So the lack of an entry in good taste and high nutrition category suggests there are opportunities for this kind of cereal in the market. So I told you that. And this is why Cheerios introduced honey, nut, and apple cinnamon versions while promoting its oat base. Now, here, this company, right, they have identified, or this brand, they have identified this opportunity, and based on that, they have introduced this. So that is how they have used uh, perceptual map, right? Then shredded wheat opted for more taste by reducing its size and adding sugar frosting or berry filling, right? This one, bad taste. So they have come to this position. Now for this quadrant, it's easy for them to move to this quadrant because they are already high in nutrition, but they have to enhance their bad taste. That's it, right? Then Rice Crisps, on the other hand, sought to challenge Cocoa Puff in the more tasty market quadrant with marshmallow and fruit flavored version, right? For this, they found it very hard for them to enhance their good taste. So it might be challenging for them. Now here, pros and cons both can be there. Anyway, the key thing is using the perceptual maps, you can identify where you are and where you are compared to your competitors, as well as you can identify where you can move based on the seen market opportunities, right? So based on that, you can develop, or you can come up with a product or new product idea. Is it clear?
Yes, madam.
Right. Okay. Then the other thing is benchmarking, right? When it comes to we are going to come up with the product idea. using our competitors, we can use perceptual maps or benchmarking and reverse engineering. So benchmarking means we are going to find the best in class product or processors, measuring the performance of your product or process against it, and making recommendations for improvement based on the results, right? So that means, like, for example, if we talk about universities, right? Now in Sri Lanka, universities are not that ranked, but no, that is a service. I'm sorry. We are talking about products. Okay. Right. So if we talk about this FedEx, right? It is a delivery service company or a courier service. So they are famous for their speed, right? So another, no, that is also now here. Actually, we have got uh, services anyway, like, right, that's fine. Anyway, you should learn the idea behind this benchmarking, right? So when it comes to a a better performing brand or the best performing brand in your product or in your industry where your company is performing. For example, it might be mobile manufacturing company. You are manufacturing a mobile phone. So for you, the benchmarking company would be iPhone or Apple company. So you can uh, like do some sort of an analysis, where are the Apple companies and where you are, in which area the company is performing really well. Sometimes when it comes to this particular company, this company's product and research and development is really high. They might be having high-end technologies or that sort of skills, and also they might be producing their product using low cost labor and all, shifting to maybe China and all, and they might be having their own. Uh, Now, rather than using several suppliers, they might be having their own chip manufacturing technology, that sort of things, right? So, likewise, you can think, okay, who is the best performer in our industry when it comes to our product, and where that particular company is, and what are the strengths of that particular company when it comes to our company or our product, and what are the weaknesses of our product, and using those strength of that particular benchmarking company, how can we overcome those things. So at that sort of a situation, you might be coming up with new ideas. Okay, this is how we can further develop our product, or we can come up with a new product idea, right? So that is the basic thing, right? For example, when it comes to iPhone company or Apple company, they might be having high-end research and development capabilities. Then you can think, okay, how can we enhance our research and development capabilities, or how can we come up with a totally new technology compared to iPhone company, right? So don't think like iPhone company or Apple company would be there in the future forever, because if you can remember, we had Nokia. It was the number one brand those days. Now that is no more there, right? Because they uh, didn't pay attention to latest market trends, right? So likewise, if you want to compete in the market, you have to pay attention to the best performing companies, and maybe you can come up with a better idea. Then you can come up with a new product. Sometimes, yes, that might be the latest trend where your target market will catch us and use it, right? So that is how you can use benchmarking. Is it clear?
Yes, ma'am.
Right. Then we have something called reverse engineering. That means we have to carefully dismantle and inspect a competitor's product to look for design features that can be incorporated into your own product. For example, if it's Samsung can an iPhone, buy an iPhone, and you dismantle it, or you, I would say, uh, yeah, you dismantle it and you separate the parts, and part by part you search, okay, what is this part, how that is different from our product. So something like that, you in depth, you do some sort of an in-depth observation, inspection or examination when it comes to that particular product's features, parts and all, right? So using that, sometimes you can come up with a better phone. So that sort of things can be done, but I don't know, there might be some sort of copyright issues and all sometimes, but that is also possible, right? So this Ford brand, that which is famous for vehicle, they have used this approach successfully in its designing of the Taurus automobile, assessing 400 features of competitors' products and copying and adapting or enhancing more than 300 of them, including Audi's accelerator pedals, Toyota's fuel gauge accuracy, and BMW's tire and jack storage, right? So not only one, you can come up with several competitors' product, and you can observe them and introduce a better product to the market. So those are the ways how we can come up with new product ideas, right? It might be from R&D, maybe from customers or competitors, or it might be using again new technologies, or as a result of market survey or anything. You can come up with new ideas, right? Then so I think I explained you like R&D is important. Yeah, R&D is important because from R&D we can come up with superior technology and all, or creative ideas. So that might be attracted to the customer. Then once you have actually come up with product ideas, it might be like one or two ideas actually, right? Imagine you are in the mobile phone manufacturing industry. So you might have come up with maybe one or two ideas, right? Idea one, idea two, and idea three, right? Now, keeping those ideas, then you think, okay, which ideas can be actually implemented, right? So as a manufacturing organization, you might be having several product development ideas. Okay, we are going to develop a phone. That phone would be like this. That is idea one, or it might be having another version, or third version is like this. So likewise, you might be having several ideas, right? So out of those several ideas, then you think, okay, actually can we implement these ideas and produce product for sure, right? So then what you do, you have to conduct a feasibility study, right? So a feasibility study means it's like from the marketing perspective or the demand perspective, you see whether there would be sufficient demand for this product idea. Then as the company, whether we will have sufficient finance, or as what as a company, again, whether we will have sufficient technology and skills. So likewise, we have to check whether these generated ideas are actually implementable or feasible, right? So that is what we are doing. So marketing takes the idea that are generated and the customer needs that are identified from the first stage of the design process and formulates alternative product and service concepts. The promising concepts undergo a feasibility study that includes several types of analysis such as market, economic and technological, as well as strategic analysis, right? So market analysis means it assesses whether there is enough demand for the proposed product to invest in developing it further, right? Now imagine we have three product ideas, right? For the, it might be a phone, so there might be several ideas or several concepts, as this says, right? Several concepts might be there. So you first do, okay, you do a market survey, you go to your some, select some customers and ask, will you, would you like to buy this sort of a product? So overall, once you have done the survey, you might see, okay, there is a sufficient demand, but for this second concept, no. Third, yes, right? So this is the marketing feasibility or market feasibility, right? Then the other one, now if we don't have sufficient demand, there is no point of further considering this second idea. Then you will be considering about first idea and the third idea. Then then you are going to do this economic analysis. That means it looks at estimates of production and development costs, compare them to estimated sales volume. Now from this market analysis, we identified whether we have sufficient demand. Then we observe, using this product concept, what sort of production and technology and all we will need. Based on that, you do how much cost would it cost, right? So is it profitable to produce this product and sell in the market? Then based on that, you have to do this economic analysis as well, right? So I'm sorry, I will use it here. Do this economic analysis. Again, we'll say for both the items, yes, that is economically feasible or profitable, right? Then technical and strategic analysis. Once these two analyses are passed, then we move to technical and strategic analysis that answers such questions. Does the new product require new technology? Is the risk or capital investment excessive? Does the company have sufficient labor management skill to support this new technology? That sort of things are considered, right? That means if you have sufficient technology, or if you don't have, if the company is rich enough to purchase that new technology, and if the company has sufficient skills, yes, technically you are feasible. Then on the other hand side, strategic analysis, that means by producing this product to the market, are you going to compete really well, or will that give you competitive advantage and all? You have to consider those things as well. Competitive advantage in the sense, that means if you have like unique skill or unique capability technology compared to your competitors, yes, you can of course compete in the market. Like Apple, they have R&D, that might be their unique capability, so based on that they compete in the market. So likewise, does this new concept, does it count under your competitive advantage and strategically feasible? So you have to consider that, right? Okay, so out of, now let's say when it comes to this technical and strategic feasibility, only concept one got passed, other one got failed. Then you carry only this concept one for further development process. Is it clear up to that point?
Yes, madam.
Okay. So once the feasibility study is done, then you write the performance specification for the product concept that passed it, and then based on that, you have to go for these further stages, such as rapid prototyping, that includes form design, production design, and functional design, right? So when it comes to performance specification, that means they describe the function of the product, that is what the product should do to satisfy customer needs, right? So customers might need a phone which is very attractive and the storage capacity is so high. Now, for example, when it comes to Apple, they have Apple, the intelligence system. Using the phone and the other devices, everything can be linked. So that might be a plus point for the customers might be looking for that, or that is the satisfaction point of the customers when it comes to this particular product. So that is uh, so performance specifications, yes, they do explain, okay, what are the things that or what sort of things in your product satisfy your customers, right? So those things should be there, right? So when it comes to this performance specification, those things should be there, and based on those performance specifications, we are thinking of design. That means how the product is developed, that means what is the size, the material, and all. Production design, that is actually how the phone is manufactured, what sort of skills and machines and all, and the steps of the production, those things. Then functional design, it's all about how easy to handle the product by the customer. Maintenance is easiness, that sort of things will be designed, right? So we are going to talk about these things. uh, so when it comes to this rapid prototyping, designers take general performance specifications and transform them into physical product or service with technical design specifications, right? The process involves building a prototype, testing the prototype, revising the design, retesting, and so on until a viable design is determined. So rapid prototyping, it creates preliminary design models that are quickly tested and either discarded or further refined, right? So simply the in this rapid prototyping stage, right, we develop a sample of the product concept that we have in our mind, or passed the which has been passed through these feasibility studies, right? So we are going to develop a sample of that. It might be either electronic version or physical form, right? So that is the simple idea. So once the prototypes are developed, those might be further evaluated, and sometimes that prototype might be discarded and come up with a new one, or further without discarding, it might be further developed. So that is the idea. So uh, so it's important to designing these actually the prototypes, right? Now when it come now, I have been in the industry for some time. So when it comes to this product designing stage, actually it might be the prototyping stage. Yes, it is not just the designers, they get together and design the design. Yes, they do some basic stuff, but they call up a meeting. There we have this production department, technical department, sometimes the procurement department, and everybody gets together and discuss, right? So the designing team, they say, okay, this is what we have designed, this is the material that we use. So is it possible to manufacture these on the production floor? Then if there are some uh, infeasible points, the production department they raise it. Then technical department, if they have some gains points, they raise it, right? Procurement, they come up with some sort of ideas. When it comes to this particular material, there are no sufficient suppliers who can provide it. So likewise, when it comes to designing stage, it's important to get together as a team, or having a team from different departments and discuss and design it, because designing designing impacts production and customer satisfaction and cost of maybe manufacturing and everything, right? So so if we do not do that at the very beginning properly, and if you have to change the basic product design at the manufacturing stage, it might be very costly, right? Therefore, it might be very costly. Now, once a product is designed and it is ready to manufacture, if the manufacturing department is saying, "Oh, we are sorry, we can't manufacture this using this existing machine, we might have to purchase a new machine," it might be costly. Or again, designing team, they might have to change the product. Sometimes for this particular already developed product, uh, purchasing team, they might have ordered material. So it is a very costly process. Therefore, it's important to do this at the very beginning, right? So uh, so this is called actually concurrent engineering or concurrent design, the simultaneous development of product design functions with open and interactive communication existing among all team members for purpose of reducing time to market, decreasing cost, improving quality and reliability, right? So yes, I did not touch these things. Now, as I told you, if we do everything from the very beginning, if we design the right product at the very beginning, which satisfy customers as well as internal requirements, yes, we can quickly out a product to the market within a shorter period of time. Cost can be decreased, and also we can improve the quality because everyone is supportive. Production, they know, okay, this is the exact machine that you should use. Then the procurement know, okay, this is the exact material we should purchase. That sort of things are there, and everyone is very supportive. Product will perform its intended function as it says, which is called reliability. So previous, this is like the concurrent engineering, everybody gets together and discuss. This is like we have functional areas, or was among between the functional areas there. We don't know what the other person is doing, what are their barriers of feasibilities. Therefore, there might be changes in the product design frequently, and it will reduce the enhance the time that will take to out your product to the market, right? uh, so this is the idea behind this concurrent engineering. Was it clear or not clear?
Clear, Manu.
Right. Now we are in the prototyping stage. Again, we are developing a physical product. It's a sample. So as I told you, we have to get together and design it. And when it comes to designing this, we have to consider, as I told you, form design, functional design, and production design, right? So form design means physical appearance of the product, its shape, color, and size and style, right? So when it comes to again shape, yes, the manufacturing team would say, okay, for this shape we might need a new part of the machine. When it comes to concurrent design, right? Color, size, and style, again for the size it might be some machine requirements as well, right? Then the functional design, it is concerned with how the product performs. It seeks to make the performance specifications of fitness for use by the customer, right? So functional design means, are we going to satisfy customers' requirement using these features, right? So there are three things that we are considering under this functional design: reliability, maintainability, and usability. So reliability means the probability that a product will perform its intended function for a specified period of time under normal conditions of use, right? So that means reliability means we say, okay, this product can be used. If you are going to purchase a washing machine, we say, okay, this can be used for 1 year without any issue. But you have to maintain that properly, right? Uh, without, like, if you drop it from the first floor, from the second floor to the first floor, if it is broken, that doesn't mean it is not reliable. That is out of or beyond normal conditions of use, right? But if you maintain that properly under the normal condition, under the normal way of usage, if it functions properly, like uh, within 45 minutes, if it washes your clothes properly and dry your clothes maybe using another 15 minutes, and if your clothes are very well cleaned and dried as they have specified, yes, reliability is there, right? So that is the idea. Then maintainability, or this is alternatively called the serviceability. It refers to the ease and the cost with which a product or service is maintained or repaired. How easy to maintain your product when it is broken, or how much would it cost to maintain it? So that is the idea, right? So when it comes to purchasing vehicles, we consider that, right? When it comes to Toyota, they say, okay, parts are highly available, parts are very less costly, so we go for Toyota. So when it comes to BMW or Benz, parts are not highly available in Sri Lanka, they are costly, so we are not going to purchase that because the maintenance is very hard. So that sort of things also should be considered when it comes to designing your product. So that is the idea, right? Uh, okay. Was it clear up to that point?
Yes, ma'am.
Right. Sometimes, apart from those availability of parts and easy to maintain instructions, how you give your customers instructions to adjust the malfunctioning of your product will also be important under this maintainability, right? And also specifying regular maintenance schedules for is part of maintainability, as is proper planning of availability of critical replacement parts. Now, when it comes to air conditions, yes, we have to use some I don't know, like periodic maintenance are there, so you have to do that properly. So when you are going to purchase an air condition, they guide you, right? So you have to do that accordingly. Otherwise your product will not be functioning well, right? So and also, if you have to replace a critical part, as the manufacturing organization, you have to inform your customers, okay, after 5 years you have to replace this, or battery that should be replaced every year or every 5,000 kilometers. So likewise, you have to advise your customer. So that is also part of maintainability, right? So if the replacement frequencies are very less, maintainability is high. If the frequencies of maintenance is very high, that means maintenance is quite hard. So that is the simple idea. Then usability, that means easy to use, of how easy to use your product. Right now, for example, if it's going to be maybe an a Nokia phone or something else, any other Chinese phone, sometimes you might not be very familiar with the interface and all, right? And but now, if you have used MacBook or iPhone, it is easy for you to handle it compared to some other maybe phones, right? So how easy to use your product, that is the idea behind this usability, right? So it is a combination of factors that affect the user's experience with the product, including ease of learning, ease of use, ease of remembering how to use, frequency and severity of errors, and user satisfaction with experience, right? So Apple revolutionized the computer industry with its initiative, easy to use design, and continues to do so with its sleek and functional iPods, iPads, and iPhones, right? And also, when it comes to Apple, they have one connected system, and all the devices of one consumer, they can link them together, so that is very easy actually, right? So poor usability examples are those that can tell whether to pull or push. So we don't know whether to push or pull, we might be confused. And remote controls which move and move buttons and smaller size for multiple products. So yeah, there are some, even air conditioners, when we have so many buttons, it's very confusing, we don't know how to operate them. And maybe TV remote controllers and some other machines, if they are having some sophisticated items or sophisticated features, sometimes it's not easy to use, right? So if your product is designed in such a way that usability is high, yes, that is a plus point. Is it clear up to that point?
Yes, ma'am.
Yes, ma'am.
Okay, now we are in this stage. We talked about idea generation, feasibility, then rapid prototyping. Under that, we covered form and functional design, right? Uh, right. Now we are going to talk about the product design, right? Uh, Sorry, production design. That means how the product is going to be manufactured, right? So designs that are difficult to make often result in poor quality products. Now, when it comes to designing your product at the initial stage or at the prototyping stage, that should be easy to manufacture as well. Otherwise, if your product is very sophisticated, if it is hard to manufacture, manufacturing team might not be able to manufacture it as you plan, right? Because unnecessary features are there, so many features are there, so many parts are there, complex, sometimes complex machines might have to use. So the end outcome will not be very pleasing or high quality. Therefore, when it comes to designing your product, right, you should try to match that with the production department's capability, right? So otherwise, as I told you, there might be some late changes, it might be costly and disruptive. So we can avoid that, right? uh, So when it comes to this production design, right? So you have to make your product very simple, right? So there are very recommended approaches that you can consider when it comes to this production design. You have to simplify your product, or simplification, that means reducing the number of parts or assemblies and options in a product, right? So uh, here we have, like, in the first picture there are so many nuts. This might be very confusing for a manufacturer or a assembler. Then they have further simplified this, having some additional two parts only, right? Then they have further simplified it in a easy manner of producing it, right? So you have to think about this simplification when it comes to designing your product, because although you produce or design a very sophisticated product that should be manufactured, if the manufacturing team cannot do that properly, if they do not have sufficient skills and those things, or if it takes so long, if the operating team becomes very confusing, that is not a very successful thing, right? Therefore you have to make your product very simplified. Yes, you should ensure you have function or performance specifications or functional design. At the same time, you have to ensure, yes, this is manufacturable, right? So that is the idea. Then standardization, commonly that means commonly available or interchangeable parts are used. So makes possible the interchangeability of parts among products, resulting in higher volume production, purchasing, lower investment in inventory, easier purchasing and material handling, fewer quality inspection, and fewer difficulties in production. For example, when it comes to, let's say, cars, right? For any car you can, sometimes, I don't know, not any car, sometimes for, maybe there might be a car range of cars, they can use the same battery, right? So battery is a standardized product, so it is commonly available, that can be used for many products. So you can have standardized parts when it comes to your production design as well. For example, if you are going to produce a car, sorry, if you are going to produce a phone, right? For your company's phones, you might be having a specific battery, right? For any version you can use that. So sometimes uh, yeah, that sort of things can be used. Resultantly your production design becomes very easy because of this standardization, right? And sometimes for cars it might be the light bulbs. uh, for many cars you can use the same light bulbs within your organization. So that sort of things are there. Or the seats when it comes to vehicles and all, right? Um, then the other one is modular design. Modular design means it combines standardized building blocks or modules to create unique finished products, right? So as I told you, standardized parts and the modular design, those are interlinked. Standardized parts are the parts that can be used commonly in many products, right? For phones it might be battery, right? For vehicles it might be seats or lights or tires or car battery or car chassis, right? So modular design is common in electronics industry and automobile industry. Here, Toyota's Camry, Corolla, and Lexus share the same body chassis. Even, yeah. So using the body chassis, same body chassis, they might be developing different cars. So that is a modular design. Then even Campbell Soup Company practices modular design by producing large volumes of 4 basic broths. So this particular company, they produce 4 basic broths, and for that they add special ingredients and come up with 125 varieties of finer soup production or products. So that is an example for this modular design. Is it clear?
Yes, madam.
Right. So here again, design for manufacture, that is a part of production design. So that means we have that should be very easy to manufacture as well as economically feasible. That means you have to reduce unnecessary parts, sub-assemblies, uh, and highly technical tools and all. So using the standardized parts, uh, you can make it very simple. Then only it will be very easy for the manufacturing team to design it, right? So that is the simple idea. So once we have covered this rapid prototyping, so resultantly from the production design, we might be coming up with manufacturing specifications. Okay, this is how we should manufacture. This is the machine that we have to use. This is the first step that we have to do. Likewise, you might be coming up with manufacturing specifications as well as design specifications. That means from the product design, this is the size, this is the color, this is the shape, okay, this is the length and the width, something like that. So you might be coming up with all those things at the end of this prototyping stage. Right. So in the preliminary design stage, prototypes are built and tested. After several iterations, a pilot run of the process is conducted, right? So as I told you now, once the prototypes are done, we come up with manufacturing and the design specifications. Then we have to introduce the product to the manufacturing team. Before that, with the involvement of the designing team and the technical team and all, the product is or as a sample product is manufactured in the manufacturing flow, right? So there also we might be coming up with some adjustments to the final product, final design or the manufacturing specifications. So we might be doing some adjustments, and once we have, it might be with several runs, 1 or 2 or 3 runs, it depends. And once that is done, we might be finalizing, okay, this is the finalized product, this is the final design, and this is how we are going to manufacture it, or manufacturing specifications, right? In this way, the design specifications for the new product have considered how the product is to be produced, and the manufacturer or delivery specification more closely reflect the intent of the design, right? So that is the simple idea. Was it clear?
That's right.
Right. So once the final product is finalized, we can provide that to the market. Sometimes based on the market feedback and all, we might be slightly changing our product sometimes. Yeah, so as I told you, final design is finalized, so we might be giving instructions to the manufacturing flow, including these are the equipment tools that we are going to use. For workers, we might be giving, okay, this is what you have to do, that sort of things. And sometimes we might be using automated machines to manufacture your products. For that, computer programs need to be designed, right? So design changes, we should try to minimize them. Otherwise, as I told you earlier, it will take some time to deliver your product to the market, and it will be costly as well. Then when it comes to this designing, you can do it either manually or you can use technology. Nowadays, you can depend on technology. So the one technology is computer-aided design. So it is a software system that use computer graphics to assist in creation, modifications, and analysis of a design. That means it, rather than manually drawing it using computer uh, softwares, you can have the 3D form of your design, that sort of thing. So by having a look at this video, you will get that understanding. Can you see this screen, YouTube?
Yes, ma'am.
Right. So I hope you got. So using this sort of softwares, we can like develop, design our products and have an idea about them rather than manually producing them for several times, right? Then the other one is computer aided engineering. So computer aided engineering retrieves the description and geometry of a part of CAD database and subject to testing and analysis on the computer screen without physically building a prototype. So in CAD, yes, we can now build, okay, inside a house, okay, this is how that happens. Or it might be a car, okay, this is the appearance of the car. But when it comes to cars, it might be the body's power. When the car hits on a certain mountain or a rock, what will happen to the car? What should be the density of the body parts or something like that? If you want to test your product design, yes, you can do that using softwares nowadays that is known as computer aided engineering. So when you want to do that, it's actually very easy, right? So you will have a look at this video and then get an idea. Was it clear? Yes or no?
Madam, clear, but there was no sound. It's not problem.
Oh,
We can
really?
identify.
Sound, it didn't, previous one also you didn't hear?
Yes, madam.
Oh. Mm. But they like nothing was just there was just background music. So don't mind, but for the next one. You don't have Sumo Teams, right? Mm, I don't know how. That's fine. Anyway, the idea is clear, right?
Yes, madam.
Right. Okay. Then then Oops, sorry. You can see the screen, right? The slides?
Yes, ma'am.
Right. So the next technologies like computer aided design and computer aided manufacturing. That means like, as I told you previously, sometimes nowadays things are manufactured automatically using machines only with the less involvement of people. So at that sort of a situation, so this designing, prototype designing, testing, and the finalizing product, everything is linked, and the product is finalized. The codes for manufacturing of this particular product, it might be the parts of the product for certain machines that might also be designed and maybe linked with the respective machines that we use to manufacture our product. So that is the idea behind this. And I don't know whether you will hear the sound, but I think you can, since you have the links, you can copy and listen to that later. But I'll try to show you this. I'm sorry about the sound. So this is what it explained. So we design the product. If you want, you can do some adjustments. Then this design turn into program instructions outlining exact steps to make the product. Then design is fed to the machine, robots or equipment. Then it would be manufactured like automatically. So that is what it. Was it clear? Is it clear? Computer-aided design and computer-aided manufacturing? Yes, ma'am. Right.
Yes, madam.
Okay, then so now once we have designed the product, right? Uh, Before making it the final version, right? So it's better if we can pay our attention towards to the quality aspects of our product. So quality matters a lot as well. Maybe during that concurrent design stage, we talk with the quality team or the respective teams with about that. So as as an initial as not an initial an important step when it comes to a product quality, since it is very important, what we have to do, we have to ensure whether our quality aspects are entitled or included in our design product. So before finalizing that design, formal procedures for analyzing possible failures and rigorously assessing the value of every part and component should be followed. Three such techniques are failure to mode effects analysis, fault tree analysis, and value analysis. Simply, uh, to assess the quality or review the quality of our product designs, we can use several techniques. So we are going to talk about them. So failure mode effect analysis, it is a systematic approach of analyzing cause and effect of product failures. It begins with listing the functions of the product and each of its part. Failure modes are then defined and ranked in order to seriousness and likelihood of failure. For example, so this is the idea behind this failure mode effects analysis. Now this is about a potato chip, right? So potato chip, the failure modes would be, it might be broken. That is a failure point. Stale, that is a failure point. Too salty, that is a failure point. So each of the failure modes are identified and their causes are also identified. For example, stale, why the potato chip goes stale, low moisture content, expired shelf life, or poor packaging. Then why it is broken, too thin, too brittle, rough handling, rough use, poor packaging. So those are the causes. So now when uh, customers find potato chips with these failures, what are the effects of them, right? For example, I refer to broken. So when the customers have broken chips, they can't dip, poor display, injuries in mouth, choking, perceived as old or lost sale, right? Lost sale is a uh, very crucial effect due to the product failures, right? Because customers won't be there within your organization. So once you have identified, okay, these sort of, so we can do this with the prototyping and all, testing and all, right? Then we can get the corrective actions. We can change, for example, for broken chip, We can change the recipe, change the process, change the packaging. So likewise, we can identify the failure causes, reasons behind that. As a result of this failure, what are the effects? Then what are the corrective actions? And so you can list them down. So that is one method, failure mode and effect analysis. The other one is fault tree analysis, right? It is a visual method of analyzing the interrelationship among failures. Fault tree analysis, it lists failures and their causes in a tree format using two hat like symbols, one with a straight line on the bottom representing, and one with a curved line on the bottom for all, right? So now here this is, don't worry about this, I will explain now. When it comes to here, this is again that same potato chip, and the failure they have taken here is chip breaking, right? So here, when it comes to chip breaking, now before talking about this tree, we have to identify the symbols. Here, a cap with a straight line that shows and, right? Cap with the curved line that shows O. For example, chip breaking, it might be due to too brittle or too thin, right? Then here triple X's, that is undesirable solution. This oval shape one, that is for acceptable solution, right? So here chip breaking, that might be due to too brittle or too thin, right? So too brittle might be due to yeah, I'll read this one. In the above analysis, potato chips break because they are too thin or because they are too brittle. The options for fixing the problem: too thin chips, increase in thickness, or reduce in size. Right now, here we have the solutions. Right, this is a solution. So too brittle, how they are going to fix it? Either adding more moisture or few ridges or adjusting frying procedure. Here too thin, they are going to increase the thickness or reduce the size, but they have identified, since we have triple X's here, this is not a desirable solution. Then they are going to focus on this, right? Here they have shown only this one, adjusting frying procedure. That is a solution, one solution. Right, so to adjust the frying procedures, they have to do these both. That is why this is with a cap and a straight line. Amount of heat, they have to adjust the amount of heat of the cooker or whatever the pan or whatever the machine that they are using. Then the length of time, they have to adjust the time of frying the chips, right? So that is the solution that they have seen, right? So the problem of too brittle chips can be alleviated by adding more moisture or having fewer ridges or adjusting the frying procedure. To adjust the frying procedure will be chosen, which leads to question of how hot the oil should be and how long the fry the chips. Once these values are determined, the issue of too brittle chips and thus the chip breakage is solved as indicated, right? So they say once this is done, this problem is solved. So likewise, you can use this fault tree analysis to overcome issues within your product design, right? Then yeah, the other one is value analysis, right? The value analysis, here we have value.
Madam, excuse me.
Yes.
Madam, can you explain again fault tree analysis?
Yeah. Here, fault tree analysis is, now we identify maybe during the designing stage, okay, we are producing a chip, so that chip is breaking, right? So we have identified what are the reasons for that. It might be due to too brittle or too thin, right? So they have identified the reasons. So they have looked, or then you can look for the failure points. How are you going to overcome them? Right here, the main issue. Here, the reasons for that, right, or the causes for that. Then these are the corrective actions that you think, right? So too brittle, for that they think, okay, we should moisture the chip, or we should have few ridges or adjust frying procedure. For too thin one, they have thought, okay, we can increase the thickness or reduce the size, but they have identified this is not feasible, maybe due to some issues, right? Or else if they are going to enhance the thickness, that might not be uh, the expected level of or that might be against the expectations of the customers, or something like that might happen. Therefore, they have considered these as undesirable solutions, right? Then they have thought, okay, adjusting frying procedure would be one solution. For that, they should come up with adjusting the heat of the maybe the fryer and frying time, right? So that is how they have overcome. I don't know whether they have overcome. This might be one way of overcoming existing issues of your designing product, right? Based on your product, there might be different ways, right? Clear or not clear?
Yeah, madam. Okay.
Now, sometimes for your one, it might be introducing an oil, right? It might be very smelly, right? For that, sometimes you might be having two courses. I don't know, you might be having two or more courses. For those courses, you might have identified those courses, and to correct those courses, you might be coming up with certain solutions. Those solutions might be feasible or not feasible. Feasible ones, yes, you can think, okay, what sort of further actions we can take, that consider under this stage actually, right? Clear or not clear?
Clear, madam. We can find the solutions to the existing problems.
Yes, that is the idea, right? Then when it comes to this value analysis or value engineering, now remember, value analysis is with existing products. Okay. Value engineering is with newly developing product, right? So now we here under value analysis or value engineering, what we are going to do is we are trying to eliminate unnecessary features or functions in product design and adding value by enhancing performance or reducing the cost, right? So I'll explain how we can do it. I'll take maybe an existing product. Let's take a pen drive, right? We have developed a pen drive with a cap, something like this. Okay, and then let's say this is storage is 1 GB. Okay, then the selling price, it might be let's say 800. Then let's say the current cost is 500. Let's say so. Is it clear? Right? The storage is 1 GB, it has a cap. Then the selling price is 800, cost is 500, right? Now when it comes to this, since this is an existing product, value analysis, we analyze, we identify, okay, this cap is unnecessary. Customers say they lose it all the time, right? And this chip is damaged due to that. So as a solution, we can remove this cap, and we can think of, okay, how we are going to protect this. That is the most important part here. And sometimes this length might be very lengthy. No need to have that lengthy chip, right? So what we are going to do, we are going to reduce the length of the the pen drive, and we are going to remove the cap, and instead we are going to add a button here. So using this button, we can take this chip in when we are not using it, and by pressing that we can take that out, right? So we enhance the performance of this. Then we can do this at the same price, right? Or else, let's say, okay, by doing so, right, we by removing this one and this part, our cost was further reduced to let's say 400. Our cost was reduced to 400, right? So by adding this, if you are going to sell that give that cost saving to customer, you can reduce your pen drive's price to 700, right? If not, keeping the at the same price, you can maybe enhance the storage of this pen drive, maybe 1.5 GB or 2 GB, something like that, right? So simply what we are going to do is, we are going to observe the product, we are going to remove unnecessary features of that, or non-value adding features of that, and enhance either the performance of the product or give the cost saving to the customer. So that is the idea. Is it clear or not clear?
Clear, madam.
Okay.
Clear, madam.
Okay. So this might be with an existing product as well, right? So you can do it like, think, okay, we can enhance the performance, or we can reduce the cost. Okay, then when it comes to designing, you have to pay attention to the quality, as well as you have to pay attention to the environment, because nowadays people are highly aware, or the customers are highly aware about the environment, sustainable development goals, everything is concerned. Therefore, when you are going to design your product, you have to pay attention to the environment, whether we are sustainable, right? So as organizations, we have to enhance profit. Yes, that's very true, but at the same time, we have to balance the society and the environment, right? So that is the idea behind this sustainability. So it involves many aspects of design, such as designing products from recycled materials, reducing hazardous chemicals, using materials and components that can be recycled after use, designing a product so that it is easier to repair than discard, or minimizing unnecessary packaging, right? For example, when it comes to minimizing unnecessary packaging, I don't know, in Sri Lanka, we can see even the toothpaste is packed in another box. So it might be unnecessary packaging. We might be harming the environment. But at the same time, if I'm not mistaken, Unilever, they have, in some outlets, they have given customers the facility of refilling the shampoo bottle. So customers, they have to pay a price for the liquid shampoo liquid, not the bottle, right? So that is a good initiative when it comes to this designing for manufacturing. And also, like, even when it comes to design your product, if you are going to use recycled materials to your product. It might be even the packaging, right? I don't know, I'm not so familiar, but here I have seen they have mentioned these bottles are made using 99% of recycled materials. So that is a good thing, right? So because they are concerned, or they have paid their attention to the environment, right? So those days we saw, when it comes to straws, we had plastic straws. Now almost everywhere in the world, now we are shifting to paper straws, which is a very good initiative. And even here, I think still that is not practiced in Sri Lanka. Not only here, even in India, if I'm not mistaken. If you go to I would say a supermarket, if you have not brought a bag, you have to pay some money and purchase a bag. So that is a very good thing to enhance customers not to use polythene unnecessarily. So that is a very good initiative. So likewise, as business organizations, when it comes to designing products, since we are talking about designing products in this perspective, we have to pay attention to the designing, not only the material that we are using, the way we are manufacturing, we have to worry about that as well. So how we are going to manufacture, if we are going to use automated machines, what about the electricity? Are we going to have solar panels in our manufacturing factory, or the manufacturing factory, or are we going to use hazardous fuel and all? So we have to pay our attention to all those things. And even when it comes to transportation, so what sort of vehicles are we going to use? Even planning the transportation routes, we should be very careful. If you are not going to have an optimal plan, right? Optimal plan means within a very less distance, you are going to cover every outlet that you want to deliver your product. So if you are going to be very optimal in that aspect, indirectly you are contributing to the nature, you are saving the nature, because you are going to spend less fuel, and you are going to save the nature. It is great if you can use like solar panel driven vehicles and all. That is very good actually. But if still in Sri Lanka, I don't know, I don't think we have taken that sort of initiatives. Maybe some companies, maybe Unilever and all, maybe they have taken, but many they have not. So still, from that aspect, we can plan and contribute to the nature. So that is the key idea of this. And not only that, after consuming the product, if you are encouraging, as I told you, Unilever, they are encouraging their customers, come with your empty shampoo bottles and refill. So that is, it's like reusing your product, right? And sometimes some products, uh, some companies, they collect their product packages and they recycle. That is a very good initiative. And some companies, they design the product that can be disposable in an environmentally friendly manner. So all those things should be considered when you are designing your product. It is not about the product designing, using its material, how will that be harmful to the environment, the way you are producing, how environmentally friendly that is, and once the consumer has used it, how environmentally friendly the disposal process would be, right? So that is the basic idea. Is it clear?
Yes, ma'am.
Right. Okay, then the next one is quality function deployment. Here, actually, this is a structured process that translate customers' voice into technical design. Now, Again, I'm saying when it comes to either a product or a service, we have to pay attention to our customers' requirements and develop the product, right? So using this quality function deployment, what we are going to do is we are going to consider customers' requirements, and based on that, we are going to develop a product. So that is what we are doing using this quality function deployment. Right, so here we have different things. This is like a house. So here we have customer requirements, right? Based on the customer requirements, we are going to do competitive assessment. Then we are going to identify the design characteristics. Then we are going to develop a relationship matrix. And then we are going to talk about the trade-off matrix, and finally the target values, right? So we'll pay attention to them one by one, right? So the first one is customers tell they want an iron. Now, if you look at this one without having a, now we are going to talk about this, right? Here, customers' requirements are listed down, right? Quadrant 1. And this one is competitive assessment. Okay, could you please give me 1 second? Shall we take the small break and do this after that? Okay, ma'am.
Okay.
Okay, ma'am.
Okay.
Okay, we'll be meeting around. I'll give you like 20 minutes break. It's 10:05.
Okay, ma'am.
10:05. Okay. Okay, can you all hear me?
Yes, madam.
Okay. So here, as I told you, now they have identified the customer requirements when it comes to an iron. So they have listed down like when it comes to ironing well, presses quickly, removes wrinkles, doesn't stick to fabric. So likewise, they have listed down easy and safe to use. They have listed down heats quickly, automatic shut off, quick cool down, like that they have listed down, right? So here, then here you can see a number, right? So here that number, highest number, says that customers wants that aspect mostly over to the lowest rank given, right? For example, automatic shut off is less important compared to doesn't scorch the fabric, right? So likewise they have given the ranks. Then here, that is all about the customer requirement. Now here we can see the competitive assessment on the screen colored area. So competitive assessment, that means we are given, like we compare our irons. Now this is with respect to an existing iron, or maybe at the development stage we might be comparing our iron with competitors irons. So we have competitors A and B, and uh, based on the performance, right, on a scale 1 to 3, with 5 being the highest, customers evaluate the company's iron against competitors' irons, right, A and B, right? So if you look at company's iron, when it comes to presses quickly, it is at a better stage than competitors, and it would be the same with removes wrinkles, better compared to competitors. But when it comes to doesn't stick to fabric, we have a score of 2, but the competitors, they have like around 4, right? So likewise we can compare. So the company's irons excels on customers attributes of presses quickly, removes wrinkles, provide enough steam, automatic shut off, and doesn't break when dropped. So there is no critical need to improve those factors. If we are performing better than the competitors, no need of improving those factors. However, the company's iron is rated poorly on doesn't stick, doesn't spot, heats quickly, quick cool down, and not too heavy. So these are the order qualifiers. That means, like, if competitors are having that sort of features at a better level, if you want your consumers to consider your product to be purchased, you have to maintain those aspects in your product. Otherwise, consumers, they might not be considering your product when it comes to their purchasing decisions. So therefore they have identified we need to improve these features, right? So none of the items perform well on doesn't scorch fabric and doesn't burn when touched. Yeah, none of the irons perform well on that, right? Sorry, this aspect doesn't burn when touched and doesn't scorch well, right? So perhaps the company could win some orders if it is satisfied these requirements. If competitors are not performing and we are not performing, if we enhance them further, we can sometimes win customers' orders. So that is the idea, right? Then the third one is design characteristics, right? Now, to press the iron quickly or to have these features, what sort of characteristics we should have in our product, right? So energy needed to press, size of the sole plate, thickness of the sole plate, number of holes, size of holes, flow of water from holes. So likewise, different design characteristics have been identified. right? So in order to change the product design to better satisfy customer requirements, it is needed to translate those requirements into measurable design characteristics. So such characteristics, energy needed to press, weight of iron, likewise are listed across the top of the matrix. Those are the design characteristics that I explained earlier. In the body of the matrix, that means this, right? You can see minuses and pluses that shows the relationship between the customer characteristics and the design characteristic, right? So in the body of the matrix, it is identify how the design characteristics are related to customer requirements. Relationships can be positive or negative, or strong relationships are designed with circle plus or minus. So examine the pluses and minuses in the row doesn't break when dropped. The iron doesn't break when dropped by increasing the weight of the iron, right? Let's see. Doesn't break when dropped, right? So if you want your iron doesn't break when it is dropped, thickness of the sole plate matters a lot, right? On the other hand side, size of the sole plate matters a lot. Weight of the iron matters a lot, right? On the other hand side, when the weight of the iron is high, or it is high, presses quickly, it is negatively related. Like when the weight is high, pressing quickly is hard. It might be a negative relationship, right? So likewise, the relationship between the requirements and the characteristics, you have to, as a designer, you have to consider all those things when you are designing your product, right? On the other hand side, right, product design characteristics are also interrelated, right? That means thickness of the sole plate might be interrelated with weight of the iron, right? Size of the holes might be interrelated with thickness of the sole plate, right? So for example, increasing the thickness of the sole plate would increase the weight of the iron but decrease the energy needed to press, right? Thickness of the sole plate, it will enhance the weight but it will reduce the energy needed to press, right? So there's reason negative relationship. Also, thicker sole plate would decrease the flow of water through hose and increase the time it takes for iron to heat up or cool down, right? So anyway, designers, as I told you earlier, designers, they have to consider all those things, right? Was it clear up to that point?
Yes,
Yes, then you can see in the last section, it is like the target value, right? So this is it. So now we are going to measure the characteristics, design characteristics of our product and the competitors' products, right? Then we have to do some things. So measuring companies iron X against competitors A and B found that its companies is heavier, larger, and thicker sole plate. Now, if you look at this, right, energy needed to press, our product is less. No, rank. Weight of the iron, ours is higher weight. Size also ours is higher. Thickness of the sole plate, ours is higher, right? Yeah, it takes longer to heat up and it requires less energy to press and provides more steam than other, right? Our needs less energy, but our other irons, they need high energy. So likewise, we have compared our iron with others, right? and then what we have to do is we have to decide, okay, now we compare our products characteristics with competitors one, and then we have to design which product characteristics or design characteristics we should change, right? For that we have to compare the estimated impact of the change and the estimated cost, right? So their estimated impact exceeds the estimated cost, we have to make a change, right? Now here you can see estimated impact and estimated cost, right? So energy needed to press, now estimated impact, it is also ranked from 1 to 5. 5 is the highest. So impact, changing energy needed to press, it doesn't have many impact on a product. Weight of iron, it has some sort of an impact. So sole plate, yes. Thickness, yes. Material used for sole plate, it has the most impact. Number of holes, most. Then size of holes, moderate. Flow of water, moderate. These two are highest. Some moderate, no impact, right? Then the estimated cost, if you are going to change these ones, cost, yes, moderate. This has a highest, some sort of high cost, moderate, high, highest, and here less cost, right? So then when you have decided, okay, changing these will have a high impact, but cost is lesser than changing that, so then that sort of characteristics you consider to change, right? That is what this says. As long as the estimated impact exceed the estimated cost, make a change, right? That means now here if you take weight of the iron, impact is 4, cost change is 3. That means we can change this, right? Although we change, the impact, cost is there, the impact is high. Resultantly, sometimes the sometimes sales might be enhanced or something like that will happen. Therefore, we have to change it. Thus, it is needed to change several product characteristics in company's new design, such as weight of the iron, size of the sole plate, thickness of the sole plate, and those things. So those things are highlighted here, right? So that is how we use this quality function deployment. Is it clear? Simple idea. Yes or no? Could you understand it or not? I'll give you a brief summary. First, you have to identify customer requirements and rank them according to their requirements. Then compare those customer requirements with your competitors, right? You have to identify which are least performing from our company's perspective and how higher performing, right? So if you are better performing, actually no need to change your characteristics. And also when it comes to these characteristics, customer requirements, with respect to those customer requirements, you have to identify design characteristics. So once you have identified the design characteristics, you have to identify, okay, what sort of a relationship these design characteristics have with the customer requirements. Might be positive, negative, strong, positive, or strong, negative. You have to identify those things because those things might sometimes might be impacting each other, right? If you want to enhance the iron weight, but it might be impacting some other characteristics, so you have to think, okay, what is the more suitable weight? That sort of decisions you might have to consider. Then once you have identified that, sometimes among the design characteristics also you can see some sort of relationships. You have to consider those things as well. Then once you have done all those things and decided, okay, this is how once you have considered all those things with respect to our design characteristics, we are going to have a comparison with our competitors, right? So we have here it might be some sort of reverse engineering or something like that. We bring iron A and iron B and we measure them and have them marked on a matrix like this, and we consider ours as well. Then we identify which is better performing, which is not better for performing, and at the same time we think, okay, if we change a certain characteristic, how would that impact, right? So here when we are going to change the weight of the iron, sometimes it might be impacting a lot because it might impact customers' requirements like removing wrinkles, that sort of thing. So we have to identify that sort of characteristics and their cost of change as well. And there, if the cost is less than the impact of change, yes, we can consider change in those characteristics. So that is the idea. Is it clear?
Yes, very.
Yes, madam.
Okay. Then the other one is designing for robustness. That means like if you have an umbrella is an example for robustness because you can use umbrella under a sunny weather or a rainy weather. For any weather, you can use an umbrella. And also the steering and the brakes of a car, for example, should continue to perform their function even on a wet, winding roads or when the tires are not inflated properly, right? Tires that should be work properly on a wet, winding or whatever the weather condition. And if you take a four-wheel vehicle, that should be okay to, that is a robust design because on a carpet road it would be okay, and also on a muddy road it would be hilly area or whatever the area, it would be okay to drive, right? So a product designed to withstand variations in environmental and operating conditions, it is said to be robust or to possess robust quality. It is believed that superior quality is derived from products that are more robust, that robust products come from robust design. So simply a robust design that is okay to perform under several conditions, environmental or operating conditions. So that is the idea behind a robust design. So a normal vehicle, it is not a robust design, but a four-wheel vehicle, yes, that can be a robust design. Again, it depends. Is it clear?
Yes.
Right. Now we are going to focus on, now we so far talked about how to design a product. Now we are going to talk about how to design a service, right? So when it comes to service, designing a service also, we have to follow several steps. First one is service concept. So service concept might be they are, or it might guide us to adhere to target customer as well as the desired service experiences of the consumer, and based on that we are going to design the service package, then the performance specifications, design specifications, delivery specifications, and finally service delivery, right? So before talking about this process, we have to know what a service is. So when it comes to service, we have talked about this previously as well. Service provider and the customer both should be uh, available. It might be customer, might be physically or online, as well as the service provider physically or online, but that interaction should be there, right? So services can be considered as acting on people's mind, that is like education, entertainment, and religion, bodies, transportation, lodging and healthcare, belonging, auto repair, dry cleaning and banking, information, tax preparation and insurance and legal defense. Thus, all services act on something provided by the customer. That's true, right? So when it comes to education, yes, students should be there. It is it is an act of customer's mind, and the service providers may be the mind or something else. When it comes to entertainment, it might be a screen or something, right? Then the bodies, yes, transportation and airline, custom is there. We transport that person from one place to another. Then the belonging, customer's belonging, uh, vehicle service center, customer's belonging is serviced, right? Dry cleaning, customers clothes are dry cleaned. Banking, customers funds are handled, or a loan is given to customer. Then information, tax preparation, insurance, legal defense, legal services are provided to customers. Information is provided to customer, right? So services can be on these aspects from customers. Then, when it comes to the service concept, that means purpose of a service, or it defines the target market and the customer experience. Why this service is there, right? So, when it comes to this service, this educational service, this master's program, this is for maybe the doctors, Ayurvedic doctors, and their expectation maybe uh, uh, why do you take part in this, or why did you start this master's program or the diploma? I don't know, diploma or masters. Can you all hear me?
Yes, sir.
Yeah, so I'm just asking because I am trying to relate the you as an example in this case.
Actually, that knowledge helps to who enters to the administrative sections.
All right, okay, right, good. I got it. Thank you. Right. So when it comes to this service concept, the purpose of a service is that should be there, and that means simply what it defines what is the target market and their customer experience. For example, if we take a hotel, it is a service, so their target market might be it depends. If it is going to be a high-end hotel, customization is provided, like the hotel that Ritz Carlton that I referred to. So their target market would be the people who wish to have unique customer experience, and yeah, who can afford that or who want to have that sort of stuff. So that is the service concept. So based on the target market and their expected customer experience, we are going to come up with the new service concept, right? It defines how the service is different from others and how it will compete in the market. For example, if I take the hotels again, Shangri-La is different from maybe the Ritz Carlton. It might be so different from a normal one-star hotel, right? Five-star hotels are different from seven-star hotel because their target customers, their experiences, expected experience are different, right? Then sometimes services are successful because their service concept fills a previously unoccupied niche or differs from a generally accepted mode of operation. For example, Uber. Airbnb, they were not there, right? For backpackers or the travelers who want to travel from one place to another, those who could not afford well, and those who did not expect like a hotel experience, they just wanted to sleep overnight. There was not that sort of services previously. So to satisfy or to fulfill that customer segment's requirement, Airbnb was introduced, right? And Uber is a kind of a taxi service. So using an app, you can book I would say, yeah, you can get that service, right? So Airbnb is a very good example, so which fulfill that unseen market requirement, right? So those are very innovative service concepts. And Netflix, it's like they have their own if I'm not mistaken, I'm not into Netflix, so I think they develop their own contents and such as films and all, and they provide that service to their customers, those who wish to watch Netflix. Or sometimes I think they are going to have some other other, for example, other uh, films as well. For example, if it's Titanic, I think they provide that facility as well for them. So they have a different service concept, right? Then, so once you have come up with this service concept, you identify your target market and their expected experiences, then you have to think of the service package, right? So how are we going to meet our customers requirement, right? So for that, we should have a service package. That means mixture of physical items, sensual benefits, and psychological benefits. So physical items, it means, for example, if it's going to be a restaurant or a hotel, what sort of facilities, what sort of food, drinks, tableware, napkins, and other touchable commodities. If it's a hotel room, swimming pool, and other facilities, right? Then sensual benefits, that means taste, aroma of the food, and the sight and the sounds of the people. Then the psychological benefits are the rest and the relaxation, comfort, status, and the sense of well-being. So psychologically, how relaxed, how does the customer feel? Is it stressful or relaxing or comfortable? Do they feel like prestigious when they go to Ritz Carlton? How do they feel? They can. It might be some sort of a prestige for them, right? So that is a psychological benefit. Clear?
Yes, madam.
Okay, do this activity. I'll give you like 5 minutes. Okay, done. Did anyone do this? No one? No one did it? Dr. Kumutini, did you do that?
Ongoing, ma'am. Yes.
Okay. Okay, I'll give you some time then. Okay, done. Anybody?
Madam, I selected health service from private hospital.
Okay. Yeah.
Built on a patient-centered model, emphasizing shorter wait times, personalized treatment plans, advanced facilities, and higher quality of patients are through empathy than
Mhm.
public sector.
Okay.
Depend on especially concepts, following concepts we must follow. First one, attractive patients. Second one, building trust and satisfaction. Patient centered treatment, superior service quality, convenience, and advanced facilities and technology. Those are
Okay.
concepts.
Okay. Those are the service concept. Okay. What is the service package?
I couldn't write that.
Okay, so when it comes to the service concept, yeah, you have made a great attempt, and yeah, you have mentioned your target
Corrected?
their expectations. That is good, and to provide them those or fulfill their experiences or the expectations. What sort of sensual facilities, psychological, and the physical facilities you should have should be mentioned, right? So okay, good attempt. Thank you, doctor. Then, right. Then I'm going to focus on the other aspects. So, from the service package, service specifications are developed for performance, design, and delivery, right? So, in the service package, we see, okay, to provide, for example, if it's going to be a hotel, Shangri-La, okay, uh, this is the service that we are going to give our customers, a unique experience or a common standardized service. If it's going to be a standardized service, how many or what sort of facilities we should have, what sort of sensual benefits are we going to provide them, and the psychological benefits. So based on that, we are going to think about the performance specifications, design specifications, and the delivery specifications. So when it comes to the performance specifications, those outline the expectations and the requirements for general and specific custom, right? So performance specifications are converted into design specifications and finally delivery specifications. So performance specifications, for example, if it's going to be a hotel, sorry, a restaurant, it might be, we have a specification mentions like, okay, if a customer comes to our restaurant, we will serve our meal within a 15 minutes, right? So that might be for a specific or a general customer. And if you are going to customize that service, sometimes uh, there might be some variations. When it comes to customization, the order requirements might be different from the others. Then sometimes the order delivery time might be slightly higher, but the quality of the service might be high. Then design specifications must describe the service in sufficient detail for the desired service experience to be replicated for different individuals at numerous locations. The specifications typically consist of activities to be performed, skills, requirements, and guidelines for service providers, and cost and time estimates. Facility size, location, layout, as well as equipment needs, and are also included. That means simply where are you going to provide your service and what sort of a location. Now if it's going to be a hotel, where are we going to locate it, how many rooms are we going to have it, what is the design of the rooms, and what sort of rooms are we going to have, standardized or several levels, I can't remember now, several room types are there, right? So what sort of room are we going to have, several types of rooms as well, so that sort of things are there. So here again, for a restaurant, design specification might be the menu layout, what sort of menus are we going to offer, seating arrangements, kitchen workflow, and all, right? Then the delivery specification, it outlines the steps required in the work process, including the work schedule, deliverables, and the locations at which the work is to be performed. That means like waiters trained in customer etiquette and food presentation when it comes to a restaurant, right? Or when it comes to a hotel as well, uh, the waiters and the yeah, especially the waiters and the housekeeping staff, they have to be very pleasant and nicely to the staff in the sorry, the customers in the hotel. That is one sort of a delivery specification, right? Now here skill requirements means we might be identifying under design specifications what sort of skills that we need, right? When it comes to delivery, when we are contacting the customers what sort of things we have to do. That is the delivery specifications. Okay, is it clear or not clear? Can you understand what I'm saying? You don't have questions, so that is a major thing.
No, madam, clear.
Sure? Okay, I think
Yes.
if I'm not mistaken, your assignment would be from this. Let me check. Yeah, I'll just share. Oh yeah, this. How many students are there in your class? $22 or more than that?
Around 30, madam, I think.
Okay, I think simply you can have 3 groups, right? Consisting of 10, and it is consisted of 2 tasks, right? Task 1 and task 2. So the task 1 is select an existing product in the market that need further development based on changing customer needs and identify new customer requirement that has not been yet satisfied. Using this chapter's knowledge, you can come up with a new product, right? You have to explain the each product development stage, right? Using pictorials if possible. Those can be hypothetical dimensions and all. Then the other task is select one function of a service organization and study it properly. I'll be talking about a service blueprint concept. So you have to come up with a service blueprint, right? So those are the 2 activities I have given you the guidelines and all. I'll be sharing that with her. Got it? Is the assignment too easy or what you want me to change it? So basically your assignment is a group assignment. Please let me know if you want me to allocate you into groups, or if not, you can have your own groups. What do you prefer? You want to have your own groups, or you want me to?
Madam, can you explain briefly again?
The
Assignment?
assignment? Yep,
Yeah.
sure. Can you see the screen?
Yes, madam. We
Okay.
can see.
Now, this is a group assignment, not an individual one, right? So since you two guys told me like you have 30 students in your class, you can form 3 groups, including 10 students in each group. Okay, clear? So every student has to contribute, because your contribution needs to be mentioned, right? So group members might receive different marks based on their level of contribution and engagement in group activities. That means you have to prepare a table, student ID, student name, and their contribution, what part this person did. Group members should communicate with the lecturer in advance prior to the submission if there are any group conflicts that cannot be resolved, right? So if there are conflicts, or if you can't even form your own groups, please let me know. Then this assignment is subject to 30 marks of your final grade, right? And for this, that means 30 is from this, and the 70% is from the final exam paper. Uh, so in this assignment, there are 2 tasks, right? Both the tasks are from this chapter, right? So task 1 is you have to select an existing product in the market. It might be with respect to your area, Ayurvedic product, right? So select an existing area in the market that you feel like it needs further development based on changing customer needs, or identify new customer requirements that has not yet satisfied via a good, right? Then using, it should be a product, right? Not a service. It should be a product. It might be a cream or an ointment when it comes to your aspect, or it might be, I don't know, any other uh, equipment, okay, or a tool. It depends, or a food item or something like that. Using your knowledge and additional reading materials on new product development, explain how your identified market requirements will be fulfilled by introducing new product and modernizing an existing product. Each development stage should be well explained using pictorial or hypothetical. That means pictures. They cannot be. You are not the owners of the organization, so hypothetical pictures can be used. Dimensions are again hypothetical. Uh, where applicable, you can use them. That means like you have to come up with the idea generation. Then once that is done, you have to do the feasibility study. Once that is done based on the performance specification, prototype should be done there. For specification for the sizes, you can come up with hypothetical dimensions. Pictures can be used. Clear? For the production specifications, you have to come up with certain things. This is the machine that you have to do. That sort of things. Is it clear?
Yes, madam.
Right. And you can use whatever the techniques that you used learn today when it comes to quality reviews and other aspects where applicable, you can use that as well. Then when it comes to task 2, that is from the service development aspect, there I have not yet talked about this. I'll be talking about a concept called service blueprint. So you have to select an organization specific service function. For example, it might be your hospital. There you might be selecting maybe the pharmacy. So for the pharmacy, you have to develop the service blueprint, and based on that, you have to identify some issues with respect to this service blueprint, and you have to come up with the suggestions to overcome the failure points that you identify, right? And that is the basic thing. So once this is when it comes to service blueprint, you can develop a service blueprint for the existing service, and you can identify some issues with that. Then you can come up with the suggestions to overcome overcome those existing issues. And once those issues are implemented, the new way of delivering the service would be different. Then you will have a new service blueprint. So I prefer if you can have both the service blueprints. That is the simple idea, right? So I have given the formatting and everything as well. So deadline, it would be mostly the first day of the study leave, right? But I will talk to your coordinator and let you know about that as well. Got it?
Yes, madam. Got it.
Okay, right. So with respect to this service, now we talked about the service concept, service package. Based on that, yes, performance specifications, design specifications, and the delivery specifications. Performance specifications, it's like, again, what the customers expect from our service, right? So once those things are determined, right, and after some, if you want some pilot studies and all, you can launch your final service to the customer, right? And also when it comes to designing this service, you can use several tools, right? So as I told you, you can use the quality function deployment, which we discussed previously. Then we have service blueprints and service escapes, and final one is waiting line analysis, right? So when it comes to the service blueprint, it is the process of recording the graphical form the activities and interactions in a service process, right? So we graphically design how would the service look like, right? So this is like a service blueprint, right? Here we have several aspects, right? So the blueprint consists of 5 components or lanes: influence and the physical evidence, customer actions, on stage provide actions, that is the front office, the backstage, and the support process, right? Now here, influence and the physical evidence, that means like due to customers might be seeing, okay, they might see, okay, today's special, this signboard, right? Or the bus stop might be closer to that restaurant, or that sort of facilities are there. So those things might be influencing, or the physical evidence that might cause customers to come to your service, right? So here the yeah, okay. So or as the menu, or loyalty card, free Wi-Fi, other facilities and all, appearance and everything, those might lead the customers to come to your service, right? Then customer actions, that means what customers does, what a customer does when the customer is inside your service organization. So that is like customer places the order, and customer waiting, customer receives order, customer pays, that sort of activities are there, right? Then again, once now here, now I'll make this a story. uh, Now a customer sees this board, today's special sign, and he feels like, okay, I should go and see in this restaurant. He comes. So that is known as the physical evidence or the influence that caused the customer to come here. Then customer's action, customer places the order. Customer might be ordering a coffee, right? So he might be ordering a coffee. So there, the barista readies the order. Customer uh, places the order. Then the front office, the barista takes that order and make it ready, right? Then in the meantime, customer has to wait. So customer might be enjoying Wi-Fi facilities, sit-ins and everything. Then customer might be receiving the order. Barista, he or she readies the coffee and give that back to the customer, right? Then once the coffee is received, customer pays. Barista gets the card or whatever the cash, then gives the receipt, right? So this is known as, like, barista's performance is the front office. That means if you go to a restaurant, if you deal with the cashier, that is the front office, right? But now, or I would say, I can't remember, in Sri Lanka we don't see how coffee is made even at we see in barista, we see how coffee is made, we see, right? I can't remember exactly. So now when the barista or the coffee maker, if he wants, now assume like in the front office, in the front office, where the customer can see how the coffee is made, they might identify, okay, sugar is no more sugar, we want sugar to prepare this particular coffee. Then this barista or the coffee maker, he or she has to go to the kitchen, that is known as the back office or the backstage, and come up with uh, or come back with some sugar or some other raw material. So that is the back office here, okay? And also in the back office, that might be the kitchen or the warehouse or the stock room. There they might have some sort of records, okay? In the stock room we have only 1 kg of sugar to run the business. In the future, in the coming week, or tomorrow, we need more sugar, so we have to order. For that, we need to get the support service. Sometimes the barista might be telling the manager or whatever the purchasing responsible person, right? So that is the idea behind this physical evidence custom action on stage or the front office, back office, and the support processes. Is it clear or not clear? Clear or not clear? You have to tell me.
Clear, madam. Clear.
Now here you will see lines, green color lines, and they are given some names, right? So this is the first line where customer sees the signboards and some other influencers. That is known as line of influence, which cause customer to visit this particular restaurant. It might be the word of mouth, menu, or we don't know. There might be many things. So uh, influences or any other physical evidences. So this line of influence is the line where customer actions and the physical evidence or the influence that cause customers to stay in with this service organization matters. Then when it comes to customer and the front office, they interact. Customer interacts with the service provider or the front office person in the service organization. That is known as the line of interaction, or the linkage between the customer and the front office is known as a line of interaction. And also, here the front office is visible to the customer, but when the barista or the front office worker goes back to the kitchen or whatever the warehouse, the customer cannot see that, right? So therefore, we name this as the the curtain or the barrier or the it might be a door, whatever. Front office is hidden from the back office, so that is known as the line of visibility, right? So line of visibility from visibility of the point, uh, the point which is visible point which is visible to the customer is highly important. You have to maintain that all the facilities, physical evidences nicely, and you have to give that psychological satisfaction to your customer. Everything should be maintained properly. And when it comes to back office to run the business properly, they have to all the time support the front office with providing whatever the required material to ensure that back office should be closely linked with the support processes. So therefore we call it as line of support, right? So that is the simple idea, right? So it says line of influence shows activities designed to influence the customer to enter the service facility and the physical evidence to take actions throughout the service process. The line of interaction is where the customer interact with the service provider face to face. The line of visibility, it separates front office activities from the back office, right? And the line of support is where the service provider interacts with the backstage support personnel to complete their task. So moving these various lines on service blueprint allows designer to experiment with expanding, decreasing activities in each area. It's like if you want to design your business without the front office, yes, you are okay. You can start up a restaurant. Once the customer places the order, customer doesn't see how the meal is prepared. They just receive the order. That's it. So you can design your service accordingly or as you wish, or maybe based on your budget and everything, considering that, right? So that's what this says. The barista could disappear behind the curtain and prepare the coffee, or customer could serve the coffee herself or interact with the service provider only when paying, right? So that is the idea. So that's why I told you, like in Sri Lanka, sometimes we might not see how coffee or whatever the juices are prepared. But here mostly we can see how all those things are done, but not when it comes to meals. We don't see how meals are prepared. That is at the back office, but cashier would be at the front office. So it depends. So when it comes to further the service blueprinting, uh, we can further evaluate our service by looking into this service blueprint. So establish boundaries for service and decide on the level of detail needed. Identify and determine the sequence of customer and service actions and interactions. I have talked about this. Develop time estimates for each phase of the process as well as time variability. Identify potential failure points and develop plan to prevent or minimize them, as well as plan to respond to service errors. Now, this is the most important thing. We using this service blueprint, we can identify the potential failures, right? So here, this example is with respect to a shoe buffing service. I would say shoe buffing service. Yeah. So they have calculated like standard execution time and the total acceptable execution time, right? So here standard execution time is once a customer is arrived and hands over the shoe to that particular person, first uh, the shoe is cleaned or the brushed. For that it takes 30 seconds, right? Then if it is a black color shoe, you have to apply black color polish, right? So for that it will take 30 seconds. If it is correctly done, then we again buff it, right? Buff it for 45 seconds and we collect the payment from the customer, right? So for that, if we do that properly, it takes 2 minutes, right? And here, but there might be failure points as well. Once the shoe is received, once we have brushed it, even though we have a black color shoe, we might be applying brown color polish mistakenly, right? So that is a failure point. So we have to clean that color and apply the right color again. So that is a failure point, but you can maximum, there is a maximum acceptable times of failures, right? That is why they say acceptable execution time is 5 minutes, right? But not try to make mistakes like what I'm is that you have to identify that sort of mistake within your selected service organization and try to come up with a solution for that. From my perspective, to avoid this failure point, this particular company can come up with maybe a polish machine, right? This machine might be having 3 colors separately, and that might be very sensitive to the shoe color. And once the shoe is held near the machine, using the sensors, the correct color can be poured on the shoe. So resultantly, then failure point can be avoided. Okay, clear?
Yes, ma'am.
So that
Yes,
is
ma'am.
what I expect that in your assignments as well. So once you have introduced that sort of a solution, you have to come up with a new service blueprint. So there should be two. One is for the existing service, and the other one for the new service without any failure points or the introduced clear,
Okay, ma'am.
right? And here the same thing, line of visibility, I have explained those things. And if possible, try to come up with this timing and all. Yeah. Now here, again, there might be a failure point in this previous example as well. Once you have placed the order, there might be different coffee types. So the barista might be mistakenly making a wrong coffee. So for that, you can come up with a solution. Yeah, here in services, there are constant trade-offs between customer service and efficiency. So, for example, Starbucks has redesigned the role of its baristas several times, at one point reducing the number of baristas, thus requiring them to prepare several customer orders at a time. So there they might have thought, when we have less number of service providers, that means they might be focusing about their cost or their efficiency. So they might have focused on that aspect as well, but recently they have again changed. They have focused on increasing quality by asking baristas to prepare no more than 2 orders at a time, starting the second order while the first is being ready. That means they have focused on that approach to minimize the waiting time or enhance the customer satisfaction. If you go to a restaurant, if you have to wait for so long, you won't like it. You might go to another restaurant. So that might be the reason they have thought or implemented this, right? So by using these service blueprints, you can think those aspects as well. That's why I'm asking you to do this timing and all, so you can have some sort of understanding regarding that as well. uh, Again, a service blueprint can specify the exact process of serving a customer, including including whether a barista rings up an order or simply prepares the order, and can codify rules such as when to call in additional baristas. The consistency with which a service is provided is an important measure of service quality and customer satisfaction, right? Uh, yeah. So this is something additional. Like it's like how we are going to like as a barista, once the order is ready, are you going to call customers by the name or just ring or something like that? So this is like something like enhancing customer satisfaction or enhancing your service quality. That sort of things also can be considered, right? But I won't expect those things, but I expect these things in your assignment, right? Okay. Then the next one is service escapes. So since the services are so intangible that physical cues to service quality are needed, right? Of course. So that's why we talked about under service package, physical facilities and everything. So service scapes the design of the physical environment. It includes signs, symbols, and the artifacts in which a service takes place, right? So designing service escapes is highly important. It should be consistent with your service concept. And yeah, and also the this service escapes design. It includes the space and the function where the service takes place, the ambient conditions such as the music, temperature, decor, and noise, as well as the science, symbols, and artifacts. So all those things finally satisfy your customers, and when designing all those things, you have to consider we meeting the target market and their requirements. You have to consider all those things, which is the idea behind this service concept, right? Then yeah, so that is the second tool. Then the third tool is waiting line analysis for service improvement, right? So even you go to a bank, we have to, most of the time we have to wait in a queue. And if you go to a shopping center, sometimes to pay the bill you have to wait in a queue, right? So all those are service organizations or the service providers. So uh, waiting lines are some sort of an issues, and if you have unnecessary waiting time, that should be tackled, right? So that's what this says. Anyone who goes shopping, to the post office, or to a movie experiences the inconvenience in waiting in line. Not only do people spend time waiting in lines, but machinery waits in line to be serviced or repaired. Trucks lined up. Oh, yes, of course. If you go to a service center, car service station, sometimes we can see, yes, vehicles are being waited in queues to be serviced, right? So that sort of issues are there. So waiting takes place in virtually every productive process or services, right? So in a waiting line, when we are going to wait in a queue, it's all about our time. So it's important to reduce waiting time as operations managers, right? So companies are able to reduce waiting time and provide faster service by increasing their service capacity, which usually means adding more servers, that is, more tellers or more mechanics or more checkout clerks, right? So we think, you might have felt like sometimes if you go to a supermarket, if you have to wait a lot, you will feel like, imagine one of the tellers or one of the cashiers, that checkout is closed, then you might feel, oh, they should have opened the other one as well. So, or they should have opened up an extra checkout as well. So that sort of thoughts are coming to our mind. So as operations managers, we should think of those aspects. We should have, as I told you, optimal number of maybe the checkouts or the tellers and the mechanics to minimize this waiting time at a service organization, right? So however, increasing service capacity has a monetary cost, of course, right? If you want to open up a new checkout, it costs. You need a new clerk, you need a new machine and space, and everything is at a cost. So they are in lines with the basis of waiting line analysis, the trade-off between the cost improved service and the cost of making customers wait. So you have to consider, is it like, you have to compare like, how much would it cost to have new service facility, as well as how much would it cost to make our customers waiting. You have to compare those things and make a right decision, right? So for that, we have to focus on this waiting line analysis. So elements of waiting line analysis. So waiting lines form because people or things arrive at a server faster than they can be served, right? So so now imagine there is a teller or in a bank there is a person or a service provider or one counter. So that that person can serve one customer or to cater one customer. That person needs 2 minutes, but in a 2 minute time, if there are four customers, yes, of course there is a waiting time or waiting line, right? So this doesn't mean that the service operation is understaffed or doesn't have the capacity to handling the arrival of the customers. Most businesses and organizations have sufficient serving capacity available to handle their customers in the long run, right? So waiting lines result because customers do not arrive at a constant, evenly phased rate, nor are they all served in an equal amount of time. That is obvious, right? So in a bank, in the queue, there might be customers. Their requirements are totally different, right? So even though the we plan to serve one customer within 2 minutes, for some customers it might take more than 2 minutes, right? So that sort of things might be happen. And even though we expect customers would arrive in every 2 minutes, it doesn't happen all the time. So that sort of things might also be impacting in this, right? Yeah. So a waiting line is continually increasing or decreasing in length, right? And sometimes we don't see any waiting line, no customers or no queues, but in the long run, approaches an average length and waiting time, right? So, for example, your local bank may have enough tellers to serve an average of 100 customers in an hour, and in particularly hour, only 60 customers might arrive. However, at specific point in time during the hour, waiting lines may form because more than an average number of customers arrive. They have transactions that require more than the average amount of time. So the same thing that I explained, right? So they might have a plan. Okay, we are going to serve this many customers within an hour, but customer arrival rate is uh, it might be random or it might be unplanned, or arrival rate might be enhanced than we expected, and individual customer requirements might take uh, more time than we planned. So that sort of things are there. So decisions about the waiting lines and the management of waiting lines are based on the averages of customer arrival and service times, right? So we have to all the time consider about the averages, right? They are used in queuing formulas and models to compute operating characteristics such as the average number of customers waiting in the line and average time a customer must wait in the line, right? So so I previously explained basic things about why waiting lines are there, right? Then when it comes to planning or managing these waiting lines, we have to pay attention to average number of number of arriving customers, and average time that we have to spend to serve a customer, that sort of things. Based on those average numbers only, we have to make decisions, right? So waiting line system, we can see waiting lines when we have a single server with a single queue. Now here we have single server, so this is a waiting line, right? So we can see arrivals and we can see served customers. Here again we can see a served customers, right? These customers might be, these are outside customers, they might be sometimes going inside and getting their service. So the basic elements of a waiting line are, there are basic elements. First one is calling population, arrivals, servers, and waiting line or the queue, right? So when it comes to the calling population, that means the source of customers to the waiting line system, and it can be either infinite or finite, right? That means calling population means for a bank, we don't know how many customers will arrive, right? So for a hospital, we don't know how many customers will arrive, right? So the source of customers to the waiting line system, that is the simple idea behind this calling population. So calling population, it might be infinite or finite. Infinite means a large number of potential customers, that is always possible for one more customer to arrive to be served, right? A large number of potential customers, that is always possible for one more customers to arrive to be served. For example, the whole town or the geographic area. Now, when it comes to a bank, we don't know if the bank is located in Nugegoda. There might be so many customers who might be coming and joining the line, right? That is an example for infinite population, right? But the finite calling population is a specific countable number of potential customers. A specific countable number of potential customers, right? So, for example, finite calling populations are a repair person in a shop who is responsible for a fixed number of machines to work on, a trucking terminal that serves a fleet of 10 trucks, or a nurse assigned to attend only 12 patients, right? So when it comes to infinite, yes, as the service provider, we are getting this many customers only. So that is the finite calling population. Is it clear, the difference? Yes or no? No? Yes or no? Sorry, I didn't hear you. I'm sorry, I can't hear you. Could you understand that or not?
Yes, ma'am. Yes, ma'am.
Okay. Right. So now the most important thing is you have to identify the calling population, then the arrivals. The arrival rate is the rate at which customers arrive at a service facility during a specific time. The rate at which customers arrive at a service facility during a specific time, right? For example, if 100 customers arrive at a store checkout counter during a 10-hour day, we could say arrival rate averages 10 customers per hour. Okay, sorry, I missed one thing. Now, simply arrival rate is the rate at which customers arrive at your service facility during a specific period, right? Now, the rate can be estimated from empirical data derived from studying the system or a similar system, or it can be an average, these empirical data. Now, we have to identify the arrival date. Okay, during 1 minute, how many customers arrived? During 1 hour, how many customers arrived? So how are we going to know about this? that is from the actual data or the past data, right? If it is a shop, we can identify, okay, we have served this many customers within or from this time to this time. So based on that, you can identify your arrival rate, right? For example, here, if 100 customers arrive at a store checkout counter during a 10-hour day, we could say arrival average is 10 customers per hour. How did we get it? 100 divided by 100 customers arrived within 10-hour time. That means 100 divided by 10 per hour, 10 customers arrived. Is it clear?
Yes, madam.
Right. However, it might be that no customers would arrive during 1 hour and 20 customers would arrive during another hour. Arrivals are assumed to be independent of each other and to vary randomly over time, right? So now within this 10-hour day, that's why we are referring to averages. Within this 10-hour day, from the very first hour, there might be 0 customers. From the last 5 hours or 5 hours, there might be like 70 customers. So that varies actually, right? So that's why we refer to this average number. Okay. And arrivals assumed to be independent of each other and vary randomly over time. Those are varying randomly over time or varying. And customer arrivals from maybe first customer's arrival, it doesn't impact the other customer. Or first time period customer's arrival, it doesn't impact the other time period's customer's arrival. All those things are independent, right? So we have to keep those things in your mind, or those are the assumptions actually we apply when it comes to this waiting time technique, right? Waiting line technique actually. So the variability of arrivals at a service facility often conform to probability distribution, right? Listen, don't get panic. The variability of arrivals at a service facility often conform to a probability distribution. Arrival could be described by many distributions, but it has been determined that the number of arrivals per unit of time at a service facility can frequently be described by a Poisson distribution, right? So simply just forget this one. Now you can remember we talked about the arrival rate, right? Arrival rate means here in this example, per hour, how many customers arrived on average. So this has a Poisson distribution. You have to just keep that in your mind, right? Arrival rate that has a Poisson distribution, right? In given the arrival rate or how many customers arrive during a period is assigned by this Poisson distribution, or this sign, this was called lambda. This is lambda. This is lambda. Lambda. This sign is called lambda. Okay, clear? Arrival rate we have to identify that has a Poisson distribution, or it is you can signify it by using lambda sign. So how are we going to write it? It's like this, simply like this, lambda. Okay, or you can write it like this, lambda. Got it? Okay. For the models presented in this chapter, we assume there is no Okay. So here now you might have questions like, if we have like more than 2 lines, will the customers changing? Now practically we do that, right? If we are in one queue, if we see the other queue is having less number of people, we might be joining that queue. So that sort of things are impossible in this case. We assume so. We assume like these sort of things are not happening, and no refusing to join a line or leaving a line or changing lines. Those things are not happening here, right? So these are the assumptions actually. Without assuming, we can't do that. And also we have to assume that the arrival rate is less than the service rate, right? That means per hour customer, if per hour customers arrival rate is 10 per hour, then we assume the service rate is less than that. For example, it would be like 9 per hour. Clear? Clear? These are the assumptions.
Yes, madam.
Right. Then the service time in a queuing process may also be any one of a large number of different probability distributions, right? The distribution most commonly assumed for service time is negative exponential distribution. Although this probability distribution is for service time, service must be expressed as a rate to be compatible with the arrival rate. The average service rate, or how many customers can be served in a period of time, is expressed as mu. Now, just keep this in your mind. Your average service rate, right? Average service rate denoted by mu. Mu is the average, right? That is mu. And it has a negative exponential distribution. Just keep those things in your mind. No need to know what exponential distribution or what is this mu. No need to know, right? So it is denoted by mu. This is how we write it. This is all about statistics. Have you learned statistics?
Yes, ma'am.
All right, then you might know, but I don't know whether you got you might have not learned about this exponential distribution or not. Might not, I'm not so sure, but Poisson you must have, right? So simply this is how you write mu. So this is mu, right? Now what did we learn? We learned about the average arrival rate that has a Poisson distribution denoted by lambda. Then we should know about the average service rate that should be all the time lesser than average arrival time, that is denoted by mu, and it has a exponential distribution, right? The queuing discipline is the order in which waiting customers are served. The most common type of queuing discipline is the first come, first served, right? So when it comes to queue discipline, it means the order in which customers are served, right? So first come, first served, that is the most common one, right? First person or the first item waiting in the line is served first. And also other disciplines are possible. For example, a machine operator might stack parts to be worked on beside a machine so that the last part is on top selected first. That means like last come first served, right? And And also sometimes machine operator might reach into a box of full of parts and select one at a random. So these might be like with respect to parts or the machines, but mostly when it comes to people, we might be going with this first come first served, right? Often customers are scheduled for service according to a predetermined appointment. Such patients at a dentist's office or at dinners at a restaurant where reservations are required. These customers are taken according to the pre-arranged schedule or regardless when they arrive at the facility. Rather than first come first served, pre-arrangements can also be implementable. Then another example is many types of queue disciplines is when customers are processed alphabetically according to their last name, such at school registration or job interviews. That is also possible. When it comes to a job interview, they might have ordered maybe based on their marks or the alphabetical order based on the name. So they might call in them like that as well, right? So those are the examples for several queue disciplines, right? And also when it comes to manufacturing operations, sometimes the job with the shorter expected processing time are selected first in order to get the most jobs processed in the shorter time period. That is also possible. If you have a job which takes like 2 minutes, you will try to finish less time taken job first, then pay attention to the other job which takes so long, right? And also when it comes to emergency services, emergency rooms at hospital, the most critical problem is typically served first. That is, of course, when it comes to hospital, severe patients are treated first, right? And so that is, those are the examples for queue disciplines. And queues also can be of an infinite or finite sizes or lengths. An infinite queue can be any size with no upper limit, and it is most common queue structure. For example, it is assumed that the waiting line is a movie theater could stretch through the lobby and outdoor if necessary, right? If they don't have any limitation of issuing the tickets and all, it might be very lengthy, right? But finite queue is limited in size. For example, the driveway at a bank teller window that can accommodate only a limited number of cars before it backs up to the street, right? If your physical facility it has a limitation, or if you have defined a limitation, that is a finite queue. But if you have no such limitation, that becomes an infinite queue. Now, when it comes to this movie theater example, sometimes movie theaters they might have their own mechanisms to control that. All the time, this is not true. So but it is possible to have infinite queues as well. Right. Then and next one, basic waiting line structures, right? So when it comes to waiting lines, there might be different structures. Waiting line processes are generally categorized into 4 basic structures according to the nature of the service facility, right? We have 4 basic structures. Right? So in technical terminology, they are called single channel, single phase, single channel, multiple phase, multiple channel, single phase, and multiple channel and multiple phase processors, right? There are 4: single channel, single phase, single channel, multiple phase, multiple channel and single phase, and multiple channel and multiple phase processors, right? So these are the 4 basic structures of waiting lines, right? Okay. So the number of channels in a queuing process is the number of parallel servers are available. Now, before talking about the single channel, single phase, we should know what is channel, what is phase, right? So number of channels in a queuing process, that means the number of parallel servers are available. Number of parallel servers are available. Now, when it comes to a retailer shop, if we have only one server, that means it might be a single channel. But in a retail shop, if we have 2 cashiers, it might be maybe there are parallel servers, so it might be multiple, right? So the number of phases, on the other hand, denotes the number of sequential servers each customer must go through to complete service, right? Number of sequential servers is each customer must go through to complete the service, right? That means, right? That means now if you want to get the, for example, the past, I would say, no, we'll refer to this, otherwise you might be get confused. An example of a single channel, single phase queuing operation is post office with only one postal clerk waiting on a single line of customers, right? So single channel, single phase, that means you go to this single clerk and you hand over your whatever the document and get it done, right? This is more commonly called simply a single server waiting line, and it is illustrated, right? A post office with several postal clerks waiting on a single line of customers is an example of a multiple channel and single phase process, or simply multiple server waiting line. As I told you, if we have several clerks, there are multiple channels, and if you have to just go to the clerk to one of the clerks to get your work done, that means you have single phase, right? But in a hospital, for example, in a hospital, uh, if you have to if you have to get a certain thing done, for example, you might have to go to the doctor, and then you might have to go to a doctor B to get it verified. Then there might be multiple phases, right? That means you cannot complete your service without attending that sequential number of servers. That is the idea, right? So the other 2 waiting line structures we mentioned have multiple phases. That is, they have a sequence of servers, right? One following another. For example, when patients go to a clinic for treatment or check into hospital, they first wait in the reception room, and then they may go to an office to fill some other paperwork, right? That is a must. Wait in the reception room, then go and fill some paperwork. When they go to the treatment room, right, the patient receive initial checkup or treatment from the nurse and followed by treatment from a doctor. This arrangement constitutes single channel and multiple phase queuing process. They have multiple phases to go through. Is it clear or not clear? Confusing? Or are you sleeping? Sleeping?
No.
Confusing. Okay. So what do you mean by channel? number of servers, right? So in a post office, if we have one clerk, that is single channel. Clear? If we have two clerks, that is multiple channel. Okay? Clear? Then phase means in the post office, we don't have to go to several, I mean, කොහොමද අපි කියන්නේ? දැන් අපි මොකක් හරි වැඩක් කරගන්න ගියොත් මොනා හරි එකකට අපිට කියනවා ඕකේ මේක ග්‍රාම සේවකගෙනුත් අත්සන් කරන් එන්න සංවර්ධන නිලධාරියාගෙනුත් අත්සන් කරන් එන්න. එතකොට ඒක ඔයගලන් අනිවාර්යෙන් ඒ දෙකටම යන්න ඕනේ. That is a must. How to meet the Grama Niladhari and the other office as well. So that is a must. So that means there are two phases or the multiple phases. But when it comes to the post office, we have the clerk, we hand over the document to the clerk. That's it. That is the only channel that we have to go through, or only server that we have to go through. There are no other sequential servers that we have to cover, right? But when it comes to, I would say, a hospital, as we highlighted earlier, right? Now here I'm referring to this again, right? In a post office with only a postal clerk waiting on a single line, that is a single channel, single phase. In the post office, practically we have to hand over the document to the clerk, that person stamp on that and do the whatever the required task later, right? Then but in the post office, if you have two clerks, you can either select clerk 1 or clerk 2. That means there are multiple channels or multiple servers, but you have to go through one, or else you have to do only one task, just handing over your document to either clerk 1 or clerk 2. That is the idea behind this phase. Here in this case, we have only one phase, right? Clear? Is it clear up to that point?
Okay.
Then when it comes to this multiple phases, that means, right, now when patients go to a clinic for treatment or a check-in to a hospital, they first wait in the reception room. Then they may go to an office to fill some paperwork, right? When they get to the treatment room, the patients receive initial checkup or treatment from a nurse. Now there is only one nurse, and that nurse check the patient, right? Followed by treatment from a doctor, right? That means maybe maybe at the treatment room, right? At the treatment room, doctor might have first examined, then based on the doctor's guidance, nurse might be further doing that, right? So that happens. So that means the patient should meet doctor first, then the nurse. That is a must for the patient. That means there are multiple phases, right? So this arrangement constitute a single channel and multiple phase process, right? Because there might be only one treatment room, so patient should wait and go to that treatment room, and there patient first have to meet the doctor, then the nurse. That means the phases, right? Clear?
Yes, ma'am.
Right. So if there are several doctors and nurses, the process is multiple channel and multiple phase processes, right? So here I'll draw you. In the post office, we have one clerk, right? Or there might be two clerks. That means multiple channels. If this is one channel or single channel. But anyway, you have to just hand over the documents. But in this case, you attend the treatment room. First, you have to meet the doctor. That is phase 1. Then you have to meet the nurse. That is phase 2. Anyway, there are only at each phase, one survey is available. That's why we call it single channel, right? But in this case, if we have in the same treatment room many doctors, yes, you can go to doctor 1 first, then go to nurse 2 next. So the phases, there are several phases, but you have at each phase you have several servers. That's why it is called multiple channel and multiple phases. Is it clear?
Yes, ma'am.
Right. So anyway, we are not going to talk about all those things. Just for your understanding, I just explained, right? So next week, I think we will be doing some calculations when it comes to this waiting line. So that would be somewhat interesting. So since time is up, I have to wind up the session. I hope you got things I explained, right? If you have any questions, you can ask me. I'll be starting from this operating characteristics next week. Is it clear or not?
Clear, ma'am.
Okay. Okay, then hope to see you all next week. If you have any questions, you can send me an email. Have you got my email address?
No, ma'am.
No, ma'am.
Yeah, I'll drop that in the chat. Oh, I'm sorry, I have not seen this. Blueprint and the master plan. Layout plan, all those things are different actually. Blueprint, it is like for the service organization. Layout, it is for the physical facility. It's like where are we going to locate the machine. It's like it might be for even for a service organization. If it's going to be a kitchen, where are we going to place the cooker, the pantry? That is the layout plan. That is different from the blueprint actually. I'm sorry, I have missed this. Got it, Dr. Kumutini?
Yes, ma'am.
Right. Okay, then I'll wind up the session. Are you going to have another lecture today? Yes, right?
Thank you, madam.
No worries.
Thank you, ma'am.
Thank you,
Thank you, madam.
Thank you, madam.
You're welcome. Now start your
Thank you, madam.